All right, let's work 6.79. This problem encourages us to make needed changes or write formation reactions for different compounds. So problem A, B, and C. We'll start with A. In A, we're combining the elements sodium and chlorine to make sodium chloride salt. This is table salt. This whole problem revolves around learning the rules for writing these so-called formation reactions for compounds. Okay? Now, in this particular case, the compound of interest is going to be sodium chloride. Okay? We don't typically write formation reactions for elements in their standard forms because their heats of formation are just zero, but this concept of formation reactions is useful for an extension of Hess's law to allow us to compute the enthalpy of reaction for any reaction we want to from tabular data, and that's why this is important. But to be able to do that, we have to understand where these formation reactions come from, what they are, and what are the rules for writing them, okay? There are really, I think, two important rules for doing this, that conditions that you need to meet, okay? Rule A, and this is real important. Always, in a formation reaction, 1 mole of the compound of interest, here that's sodium chloride, the product, always 1 mole, and only 1 mole, must form from your balanced chemical reaction. Okay? And the second rule is that elements used to form the compounds must be in their standard state. Okay? So what these reactions, these formation reactions are going to be all about, we're going to use the elements, the ingredients, to make a compound. We're going to write a balanced chemical equation to do that. Okay? Which sounds kind of silly. But it's important to understand where these reactions come from and what are the rules for doing this. Okay, so I could pose this question just by saying write the formation reaction for sodium chloride and hope that you could do that. Right now, based on the rules, then the product is going to be sodium chloride solid, 1 mole of it, and we have to make that from its elements in their standard forms. Okay. Now, for sodium chloride, it's of course sodium and chlorine. So I'm going to have sodium solid, 1 mole of that, and I'm going to combine it with chlorine. But there's a problem here that I don't like. Chlorine is a molecular diatomic gas. So it is a gas. That's okay. Its phase is okay. But it's got to be Cl2. Okay? Because that's its standard state. Now, if I do that, I got a little bit of a problem here, because now I got 2 Cls here and only 1 here. And to further complicate matters, I can't change this number. I need to make 1 mole of my product. But I can easily just make this a 1/2. And that's my formation reaction for the sodium chloride, okay? Let's try this for a different compound. Part B, what do they do in part B here? 6, 7, 9. Oh, they're taking water and decomposing it into its elements. Now that's kind of strange, because usually we make formation reactions for compounds, not decomposition reactions. Okay, so in 6, 7, 9 we're doing gaseous water. So the first change that I want to make is listing water, our compound, as a product in this reaction, not a reactant. And we're going to have to form that water from the elements. Okay, now what elements are responsible for making water? Well, hydrogen and oxygen, right? So I'll write H and O. We'll think about this for a second. Now, what are those elements in their standard forms? Well, both of them are gases, right? So write G, no big surprise. Both of them are also on the list of what? Diatomic substances. So I need to write H2 gas and O2 gas. I'm forming the compound from its elements. Again, specifically 1 mole. I cannot change that. But I could write 1/2 here for my oxygen, and then that balances my formation reaction for water. Okay, now part C is ammonia gas. So let's take a look at that, okay? So we're going to want to write the formation reaction for ammonia gas. Ammonia is NH3 gas phase. Again, the rule says I need to make 1 mole of that from what? From its elements, right? 1 mole from its elements. So the element nitrogen's involved, the element's hydrogen's involved, okay? What do we know about these? Well, they're both gases, okay, so G and G, got that. But they're also both what? Diatomic in their standard form. So I need to write the subscripts too. That's how they come packaged. Now, of course, this is not balanced as it's written right now. I need to balance it. But I can do that by making this 1/2. And making this one a little bit trickier, but I make it 3/2. I think that makes it work. Okay? Alright, so this is writing the formation reactions. You always want to yield 1 mole of the desired compound as a product. 1 mole in its normal state, if you will. You're going to form that 1 mole from the elements that make up the compound in their standard states. And you're allowed to change the superscripts out in front here, but this has always got to be 1. Okay? And your elements must be in their standard state. That's very, very, very important. And the reason why that is because we're going to come up with an enthalpy of formation from tabular data for compounds such as water or NaCl and NH3. There's delta H values of formation for these compounds. They're in appendices, okay? We need to make these elements in their standard state so that their formation enthalpies are 0 by definition, okay? And that's why it's super important to make sure that these reactions are written correctly.